Hey everyone, welcome back to my channel. This is Vikas Singh Thakur, and in this video we are going to see different parameters that is labeled on top of your battery. So this is a lithium polymer battery. I have lithium ferrous phosphate, lithium iron moly cell, or you can say another variety of lithium ion batteries are there that I will be explaining all the parameters, features, specification of it in this video. And in next video or the upcoming video, I will be explaining all the different kind of batteries or lithium ion based batteries that is highly used in portable electronics, especially when we are talking about robotics and the other FPV or drone based project. Then these are very useful and highly reliable batteries. So let's get started. So first thing is the battery configuration. It is very important to understand different battery configuration available in the market, and this configuration actually, these are the things which is actually deciding your voltage value, your mAh of the battery. You can manipulate different mAh voltage rating of your battery based on different configuration you can choose on. So before understanding different configuration, it is very important to understand the difference between the series and the parallel. So in the simplest way, when you connect two different terminals, like the negative and the positive of a battery, then this is called series. And when you connect the same terminal, that is positive with the positive and negative with the negative, then it is called parallel. So this is the simplest analogy or the simplest way you can understand series and the parallel. Now let's see different configuration that is possible here. So starting with the 2S and the 2P. So here we are talking about two of the cell in the series and two of the cell in the parallel. So as we have seen, what we actually mean by series is when we put the different terminal in the series way, like this way. So this is 1S, I could say. And when we put another pair of the cell here, so here I will be using two of this other cell. So you can see there is two different series connection here. So when we are talking about 2S and 2P, so we already got the 2S here. So two of these are series. And when we put both of these together, so here you can see when we put both of these together, we will be connecting negative of both of these cell in a same way or with the same wire, and the positive with the same wire. So here you will be getting 2S and the 2P. So two of these are in the series and two of these are in the parallel. So you can see this is the 2S and 2P. So if you are not understanding what exactly, sometimes it is little confusing. So you just need to rewatch this video again after you complete the entire video. And I'm sure and I'm pretty sure that you will be able to understand all of these concepts really good. So the reason why we are actually having series and the parallel configuration and why it is actually important is to understand that when we are going with the series and when we are connecting all of these cells in the series way, then we are actually manipulating the voltage value here. So here when we're talking about the series configuration, the voltage around each of these terminal is increasing by cell. So here we will be getting 3.6 volt around this cell, and when we move to the next cell, that we will be getting 3.6 into 2. That is when we do a small calculation here, 3.6 multiplied by 2, then it is equals to 7.2 voltage. So when we take the value around this two terminal, then we will be getting 7.2 volt around this terminal, and so on and so forth. So when we increase the number of the cell in the series, then we are actually increasing the voltage across the terminal. So when we calculate the voltage around this end of this terminal, then we will be getting 6 times 3.6. So when we let's calculate it. So 3.6 multiplied by 6 of this cell in the series, so we will be getting around 21.6 volt. So we will be getting 21.6 volt across this terminal here. So this is how the series manipulation is done. So when we are going with the series, then the voltage is increasing and the current or the the mAh value will be fixed. So but when we are going with the parallel way, so if we connect all of these cell in the parallel terminals, and when we connect all of these on with a single wire, all of this terminal with a single wire, then what we will be getting is an increased current, but the value of the voltage would be exactly the same. So here what we are actually increasing or manipulating is the mAh or the capacity of your battery. So here we will be getting higher mAh. So you just need to multiply the mAh value. So for example, this got 4 ampere hour. So we just need to multiply all of these with the mAh value. So we are having 4000 mAh across each of these unit cell, and when we put all of these in the parallel way, then we just need to multiply it with the 6. So we will be getting 2.4 into 10 to power 4 10 to the power 4, that is 24,000 mAh. So we will be getting 24,000 mAh at the end of this cell. So this is how you can actually manipulate different current value or the capacity of your battery or the voltage across each of your cell. So the next part is the capacity part of your battery. So this is very important because this is the another term parameter that most of us will be looking at before buying any battery. So milliampere hour. So what it exactly means is how much a battery can, how much current a battery could provide for a 1 hour continuously. So here we will be getting, for example, 2200 mAh, so milliampere hour. When we multiply this with the 10 to the power minus 3, then we will be getting 2.2 ampere hour. So, this is going to provide us a 2.2 ampere at for 1 hour continuously. And when we look at other batteries, for example, this got 500 milliampere hour, which is pretty less, and this is good for a small project. So it can provide up to 0.5 ampere hour. So it can give us a 0.5 or half ampere for 1 hour. So this is how the multiple different mAh and different the ratings or the the capacity of the battery is assigned here. So the best way or the real life analogy that I actually use to understand this is to think of it like an water tank. So the bigger the tank, the longer the supply, and the smaller the tank, the lower the capacity it would be having. So for example, when we are talking about 6200 mAh battery, so for example, when we are talking about this kind of the lithium ion batteries, then we'll be getting higher mAh. So this is really high for some kind of a drone or some kind of FPV or any agricultural drone that is required to work for a longer hour. Then this higher rating mAh batteries are very important for those kind of projects. Now the next part here is to understand the C rating, and this is very important term in the the battery when we are talking about FPV drone or some kind of RC car or some when we are talking about different current consumption, it's certain type of battery. Then this is very important to understand the C rating in it. So initially when I was starting with the batteries and understanding this battery, then this is a term which is very confusing to me, but over the time I got to know what it exactly is. So in the simplest way, this tell you how fast you can safely drain the battery continuously. So this the formula here is the maximum current that you can take out from your battery. So the formula here is the capacity into C rating. So as we already see what exactly is the capacity mean here, so that is the mAh part of your battery. So for example, here we will be getting 2.2 ampere hour. So when we multiply the 2.2, so here 2.2 multiplied by the C rating of it, so here you can see that we are getting 45 C. So most of the time we are getting higher C rating in the lithium polymer battery, but we are getting lower C rating in the lithium ion or lithium ferrous phosphate kind of battery. So here when we multiply 2.2 with the the C rating of it, so when we multiply it with the 2.2 into 45 C, then we will be getting 9.9 that is into 10 to the power 1. So we'll be getting 99 ampere hour. So we can take out 99 or almost 100 ampere for 1 hour continuously from this battery, and this is known to be the safe range. When we go beyond these, then it is not able to provide that much amount of current to your particular electronic circuit or different component of your battery. For example, when we are working with the BLDC or when we are working with the FPV kind of drone, then this is very important to understand different C rating here. So this is how your C rating decide how much current you can take out from your battery. So the best it is very good to understand the formula, and it is very important to memorize this formula before you actually choose different batteries here. So when we are talking about lithium polymer batteries, then this got very good amount of C rating here. So you can see this got 25 C. So when we when we multiply with the mAh here, so for example, let's see 6.2 ampere hour, so multiplied by 25 C, and we can also get 50 C at burst. That is the peak we can go for a certain limit of time or few seconds we can say. So when we multiply 6.2 ampere hour with the C rating of it, so that is 25, so we will be getting 155 mAh, so 155 ampere hour. So we can take out the current of 155 ampere for continuously from this battery, and this can provide this amount of voltage or this amount of current at a peak of it. So this is how the C rating defines how much current you can take out from your battery, and it is very important to understand the C rating before you actually choose different batteries for your project. So after the the C rating, it is also important to understand energy storage of your battery, how much energy your battery could store. Most of the time this is not labeled directly on your battery, but you can check out the the data sheet of your particular lithium ion battery or the different manufacturer that is building those battery or manufacturing those battery. But here in my lithium polymer polymer battery, I got this rating on top of the battery. You can see 137.64 watt hour. So what it exactly means is the total energy stored in the battery, or the capacity of this battery to store that certain amount of energy into it. And the watt hour could also be calculated using this formula, that is the voltage into capacity. So for example, this battery didn't got the the watt hour into it. So let's calculate what exactly would be the watt hour using this formula. So here watt hour is equals to voltage into the capacity. So here we will be getting a voltage of 7.4, which is rated on top of it. So here when we multiply 7.4 with the the capacity of the battery, that is 2.2 ampere hour. So when we multiply 2.2, so we will be getting the value of 16.28 watt hour. So this is the the capacity or the storage capacity of your battery. The higher the value it is, the better battery capacity would be there. So for example, this battery got 137.64 watt hour. So this will be having better capacity or better energy capacity compared to the lithium polymer battery here. So this will be getting 16.28 watt hour. So this is the way you can actually calculate the watt hour of your battery. So this was all the parameters and different characteristic and parameters related to your batteries and the specification related to it. So this is all the parameter and specification of a lithium ion or lithium polymer based battery. After this understanding, you will be able to understand the other upcoming videos that I will be creating. In that I will be explaining all the different kind of batteries that you can use in your project, or different kind of FPV or robotics based project. So stay with me, and if you're liking my content, then please like and subscribe my channel, and see you on the next video. Till then, bye.